Okay, so today we're going to be covering power factor. Yes, your circuit is never going to be truly resistive. It'll always have inductive reactance and capacitive reactance within it. And then we're going to go over what is an inductor, what is a capacitor, and then we're going to look at the power triangle and the acronym CIVIL. We're going to take a look at the acronym CIVIL, what people get wrong all the time about power factor, even years after their studies.
We have capacitors and inductors over here. Okay, so a capacitor is a passive electrical component that stores energy in an electric field between two conductive plates separated by an insulator called the dielectric. All right, so that's a capacitor over here. And then, what is an inductor? An inductor is a coil of wire that stores energy in a magnetic field when current flows through it. So that's an inductor. All right. So the next thing we're going to look at, now that we have the definitions out the way, let's go and look at what they do. And waveforms, one over here, and then one a little more lagged. Why is it lagged? Because time goes this way and so does the phase angle. Amplitude of I and V. What that means is that this waveform over here is lagging and this one is leading. It appears first. Okay, so if we go look at the acronym CIVIL, okay, what CIVIL basically means is that in capacitive circuits, the current leads the voltage, and in inductive circuits, the voltage leads the current. So if I tell you that my circuit is capacitive, how should these waveforms be labeled, right? Then this would be I and this would be V. All right, cool. And if I told you the circuit is inductive, yes, then this would be V and this would be I if it was inductive. All right, so this is the waveform leading and lagging is a reference to, and what do people get wrong most about this? They don't know what leading and lagging is referencing. They just go, oh, I know for a fact it's civil and current leads voltage, but it's like leads in terms of what? What does leading and lagging mean? It means it's ahead of the voltage or behind the voltage if we look at the phase waveform, which is this. That's all it means. Okay, so if I say you have a power factor of 0.8, which is normally what we rate factories at, normally about a 0.8 to a 0.7 because they have a lot of inductive machinery. So this will be a lagging case here. This is the 0.8 and how does it tie into the power triangle? All right, what the 0.8 is basically is power factor, and power factor is equal to cos theta, and this theta basically stands for like phase angle. So this theta is phase angle. All right, so we want phase angle. What we do is we take inverse cos, right, 0.8 to get the phase angle. This is basic mathematics. All right, which is approximately 36 degrees. All right, so say we have like 36 degrees over here, right? This is now our phase angle. What is this? What is this? And what is this? All right, so let's break it down. This is S, normally called apparent power, and it's measured in KVA. Can say kilovolt amp, right? Over here we have Q, which is reactive power, and it's measured in KVAR. So just remember it is exactly the same with an R behind it. And then what do we have over here at the bottom? We have P, which is measured in watts, kilowatts most of the time. And then, okay, so that's P standing for power. You can see it as true power. So we've got three triangle walls, also just the basic power triangle. All right, next time we're going to continue with electrical engineering. I'll just expand a little bit on these topics, but this is making it simple and short.